Okay, YouTube, this is my second video on graphing polar rose curves here, in which we're going to look at a cosine graph instead of a sine-based graph. So, in the last video, we kind of made some general observations about the value of A in this expression here and the value of N. And what we were able to determine basically is that A kind of directly dictated what the maximum value of our petals will be, how far they extend from the pole or the origin. And N, if N is even, okay, we say N, or let's do it this way, N odd, would basically imply that we say N even. I'm going to write without an arrow on this one. But we have N petals on our roses here, whereas if we had N even, we had 2 N petals on our roses here. And then just last but not least, we know that cosine graphs in terms of polar coordinate system of this form are symmetrical with the respect to the polar axis, or the horizontal axis in our case. Okay, so we're going to use all these things to our advantage to kind of leverage making a graph a little bit easier. And so we'd say shape. What shape would this be? With all of these, we're going to say basically it's a rose curve, is what we have. It's not a circle. We've learned about rose curves. And then what we want to do is indicate the number of petals. So we notice that the value of N here is 3, so we're going to say we have 3 petals on this curve here. Okay. We also know that, and I want to make a note here, that it's symmetrical with respect to the horizontal axis or the polar axis. Okay. The maximum value of R looks like our A value here is 5. So it is going to start on the right side instead of starting on the left side. And because it is a cosine graph, let's point that out also, but it starts on the horizontal axis. When we look at rose curves, a lot of the time we'll see that all of our cosine graphs start right over here on the right side. And actually we can demonstrate this just really quickly here. All of our cosine graphs, no matter what A is and no matter the number of roses, you'll notice that they all start over here on the right side. Okay, so we're going to use that to our advantage here. Going back and looking at this then, we could say that the next things that we want to find here are a number of zeros, okay, and actually the zeros of this function here. The thing is, because this is a cosine graph and it's going to have 3 petals, and it does start out over here on the right. As a matter of fact, we're going to count out 1, 2, 3, 4, 5 and say with confidence, I already know this point is on here. Because it has 3 petals, we can imagine the path of this. We would kind of say that it would go 1, and go to 0 there, and then we get 1 over here, 2 zeros, 3 zeros, and then back out to this point here. So in terms of the number of zeros, it is if it's cosine. We'll say if cosine, then it equals the number of petals. Okay. If it's sine, it's always 1 more than the number of petals. So we're going to say that in this case we have 3 zeros. We want to find them all. It's important that we know how many there are because we're going to set now r equal to 0. And we're going to say that 5 cosine 3 theta is equal to 0. So this leads us to say that cosine 3 theta is equal to 0. And if we were to do the cosine inverse of this, we get cosine inverse of 0 is equal to 3 theta. So what we want to know is, where does cosine equal 0 on the unit circle? And we're going to need, 3 different values here. So we say pi halves, 3 pi halves, and I'm going to say 5 pi halves. So we're going to say at pi halves, 3 pi halves, and 5 pi halves, cosine is 0. We needed to list 3 because we need 3. And if we split all these 3 ways, divide them all by 3, we're going to get 5 pi sixth. Okay, we're going to get 3 pi sixth, which is pi halves. We're going to get pi sixth when dividing this by 3. So we say these are our 3 zeros here, and those are going to be, kind of blank spots on our graph where it's back at the origin. So now we'd say the zeros, and I'm going to write them up here, and I'm going to write them in order, darn it, because I'm OCD, and we get 5 pi sixth. So what we want to do is, I'm just going to put a couple of key points on here, starting with 0. If we plug in 0, we get cosine of 3 times 0 radians, which is cosine of 0, which is cosine of 0 is 1. We get 5 times 1 is 5. So I always start at 0, and I do want to put on a couple of zeros here. That is to say, like if I put on pi sixth, I would know that I'm at 0 here, okay, essentially. And I know that if I were to skip over this and I'd say go to my next one here, which is 3 pi sixth, by the way, 3 pi sixth was my next 0, which is this pi halves here. Then 2 pi sixth, or pi thirds, I might try plugging this in between. And what we would witness here is basically, when you plug in pi thirds times a 3, it just becomes pi. And recall that cosine at pi is -1. So we say -1 comma 0. So we get 5 times -1 is -5. So basically we've got some key points here. These are going to be good enough for us to construct the rest of this graph. So knowing what we know about cosine rose curves, let's go ahead and say that it's going to start on the polar axis at this point. And by the way, this is the point. R is 5, theta is 0. And we have this in our table here right there. So the next point here we could say putting on our graph is at pi sixth radians we're going to go out 0. So in other words, here's pi sixth, we're going to have a 0 there essentially. And what's happened is it's curved back around and done this right here. And so just checking this out here, we'd say at pi thirds, which is this next one up here, we'd say at pi thirds it'd be at -5. We'd go, backwards. We'd say 1, 2, 3, 4, 5. But it's going to go down here. So basically it's curling around. And then at, 3 pi 6, which is pi halves here, it's going to be back at 0. So when we're facing up at pi halves, we're not going to go out anywhere from the origin. So this is its next stop. And so you're going to get this rose that basically looks like this. So now, a few things, just thinking out loud here. Because I know that it's going to have 3 petals, and because I know it's symmetrical with respect to this horizontal axis, I know that this part of my graph has to exist here. And I also want to know, well, how far apart are kind of these spokes spread here? Like, what is this angle, theta? And because I know there are 3 petals, we'll take the full rotation, 2 pi, and divided by 3, we say 2 pi thirds. So if I were to rotate 2 pi thirds from here, which is going to be up over here, this spoke right there, we would say going out 1, 2, 3, 4, 5. We'd say then I know that there must be a petal that exists up here, and it's going to do this right here. But here's our rose curve with the cosine curve. So that's how you would construct one of those. Cheers.